Hello, myself Dr. Kalyani, working as Associate Professor in the Department of Computer Science and Engineering of Institute of Aeronautical Engineering. In this video, I will discuss regarding software metrics. The topic learning outcome of is mapped with the course outcomes of CO1, which is identify the appropriate process model approaches and techniques to manage the given software development process. In this video, I will discuss regarding what are the software metrics, what are the categories of it. So here, the software metric is a measure of software characteristics which are measurable and countable. So quantify of each work of the software development is important in order to track the progress of the project and to optimize the project development process. So software metrics are valuable for many reasons. So they are including measuring software performance, planning work items, measuring productivity, and many other uses are for the software metrics. Why these metrics are useful? Because the increased significance placed on application quality. So the requirements are fully satisfied that are specified by the customer in order to improve the quality. It is necessary to have quality testing teams in place and define the manner of monitoring the test team goals and efficiency. So this goal is tracking is accomplished through the use of software metrics in the software engineering. Understanding software metrics and how to track them will manage programming process more effectively. The characteristic of the software metrics are quantitative, understandable, applicability, repeatability, and economical. The quantitative means that metrics can be stated numerically. Understandable means it should be simple to grasp and the methods for capturing them should be well explained. Applicability should be applied during the early stages of the software development. Repeatable when measured regularly, consistently in nature, the metric values should be the same. Economical means metric computation should be cost effective. The need for software metrics. Software metrics helps to monitor performance, plan upcoming work tasks, track the productivity, better regulate the production process throughout project management. So use software metrics in conjunction with management functions to simplify projects by building more efficient procedures, creating software maintenance plans, and keeping production teams updated on issues that need to be resolved. The importance of software metrics is identify issues very early stages of the software project and measure the progress clearly, track the project progress, enhance the decision making, improving the quality of the software process, managing the resources, facilitating the communication. So, by preventing the faults, it is possible to save the money. So, it is economical. Aids in the improvement of overall project planning The resources, cost and time can be estimated with the help of variety of models. Encourages eagerness to improve processes. Aids in a more thorough analysis of the dangers involved. The risk can be identified early and risk mitigation plans can be performed. Aids in studying indicators at each testing stage to increase problem eradication efficiency. Increases the return on investment for test automation over time. Improves the relationship between testing coverage, risk and system complexities. The advantages of software metrics are: the software system design technique can be analyzed in comparison to other designs. So using software metrics, the properties for various programming languages can be explored for study and comparison. So software metrics in the software engineering can be used to create software quality requirements. Software system compliance with the requirements and standards can be verified. It is possible to infer the effort required to design and develop software systems. The disadvantages of software metrics are: it is challenging to validate historical and empirical evidence used for verification and argumentation. Although software products can be managed, technical staff performance cannot be measured using software metrics. The available tools and working environments are utilized to define and derive software metrics, and there is no standard for doing so. Certain values are estimated using predictive models and are not always be known. The steps for software metric processes: first is characterize, establish, evaluate, and predict. So, to characterize in order to gain understanding of process, product, resources, and environment. Establish baselines for comparison with future assessment. Evaluate in order to determine the status with respect to plans. To predict, to gain understanding of relationships among processes and products. So the types of software metrics generally uses are product metrics, process metrics, project metrics, people metrics, and quality metrics. The product metrics. Product metrics are quantitative measures used to assess the characteristics of software products. So product metrics are software product measures at any stage of their development, from requirement to established system until delivery of the project at the client site. Product metrics are related to software features only. The key product metrics are generally the fan-in, fan-out, the length of code, cyclomatic complexity, length of identifiers, depth of conditional nesting, and fog index. The fan-in, fan-out is measure of number of functions that call some other function. So function call must be in and out. So fan out is the number of functions which are called by function X. So if a function called, that is, can be the fan out. If a function calls number of functions, then it is fan in. A high value for fan in means X is tightly coupled to the rest of the design and changes to X will be extensive knock-on effects. So the dependency of that function X in the fan-in value is high. So the dependent modules must be changed when the X module must be changed. A high value for fan-out suggests that overall complexity of the control logic needed to coordinate the called components. The next measure of product is the length of the code. Length of code is measure of the size of the program. Generally, large the size of the code or the program component, the more complex and error-prone that components is more likely to be. So, length of code can be measured in various ways. The most common metric is lines of code, LOC. Next is cyclomatic complexity. So it is the code section is the quantitative measure of the number of linearly independent paths in it. Majorly, it is used in path testing of white box testing. It is a software metric used to indicate the complexity of a program. It is computed based on one diagram that is called control flow graph. Based on that, the independent path of the program must be identified. Next is length of identifier. Length of identifier is a measure of the average length of distinct identifiers in a program. The longer the identifier, the more understandable the program. The length of identifier metric help in assessing the readability and maintainability of the code. So longer descriptive names generally indicate better readability and understanding. Depth of nesting condition is one more metric. So here it is a measure of the depth of nesting of if statements in a program. Deeply nested statements are hard to understand and potentially error-prone. So it indicates how many levels of deep the nested condition statements such as if, else, while, loops also. So this metric is important because deeply nested code can be difficult to read, understand and maintain. Next metric, product metric is fog index. Fog index is a measure of the average length of the words and sentences in the document. So software must be a collection of programs, the data structures as well as documentation. So here the length of words and sentences in the document is measured with the fog index. The higher the value of fog index, the more difficult the document may to understand. How to calculate the fog index is 0.04 into number of words by number of sentences plus 100 into number of complex words by number of words. Next variety of metrics are the process metrics. Process metrics are the measures of the development process creates a body of the software. A common example of process metric is length and time the process software creation of the task. So based on the assumption that the quality of the product is a direct function of the process, process metrics can be used to estimate, monitor and improve the reliability and quality of the software. How the software can withstand failures in terms of MTTF, MTBF must be used in case of reliability estimates. Variety of process metrics are static process metrics, Dynamic process metrics, process evaluation metrics. Static process metrics are directly related to the defined processes. For example, number of types of roles, types of artifacts, etc. Dynamic process metrics are simply related to the properties of the process performance. For example, how many activities are performed, how many active counts are created. Process evolution metrics are related to the process making changes over a period of time. The example metrics are how many iterations are there within the process. Key process metrics are lead time, cycle time, throughput, work in progress. The lead time is the time measure, that time taken from the initiating a process. Cycle time tracks the duration it takes to complete one full cycle of a process from the beginning to end. Throughput basically quantifies the rate at which tasks or features completed within the given time frame. Work in progress WIP indicates number of tasks or features currently being worked on but not yet completed. Another variety of metrics are the project metrics. The project metrics describes the characteristics and execution of the project. Examples include effort estimation, accuracy, schedule deviation, cost variance, and productivity. Usually the measures number of software developers, staffing patterns over the life cycle of the software, cost and schedule, productivity. The key project metrics generally involve schedule variance, cost variance, schedule performance index, cost performance index, quality metrics, as well as scope metrics, risk metrics, stakeholder metrics. The key project metrics are schedule variance SV, which is used to indicate how many projects is ahead or behind the schedule. Cost variance CV shows how much project is over or under budget. Scheduled performance index SPI shows how efficiently project is using time. Cost performance index CPI shows how efficiently project is using the resources. Quality metrics shows how well project meets the quality standards like CMM, ISO 6 Sigma. Another variety of project metrics are people metrics. People metrics quantify useful attributes of those generating products using the available processes, methods, and tools. So these metrics are the attributes like turnover rates, productivity, and absenteeism. Types of people metrics are staffing and staffing metrics, relation metric, training and development, recruiting metrics. So the retention rate is the major people metric used in the software development. Key people metrics are productivity, employee net promoter score ENPS, team collaboration, attrition, and absenteeism. The last variety of metrics are the quality metrics. Quality metrics are quantifiable measures that help organization to assess the performance, quality of product, process, service, or the system. They are a key part of the quality management. which is a systematic approach to monitoring, controlling, planning processes, activities to specific quality requirements. Key quality metrics are customer satisfaction, user ratings, failure rate, service quality, quality control, defect rate. So factors that are help to select the right product metrics are the purpose and objective. Depending upon the purpose and objective of the project, expectations and requirements of the stakeholders, characteristics and constraints of the project, availability and reliability of data sources, feasibility and cost effectiveness of data collection and analysis. So in this video, I discuss about what are the software metrics, how they are important and useful for the project management, and variety of software metrics with examples. And the references used in this video are these. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.